Okay, so we start with law of sines. And both law of sines and law of cosines are used to find the measurements of a triangle that is not a right triangle. So if these were right triangles, we can use SOHCAHTOA to find the lengths of the sides or the angles. And then what happens if they are not right triangles, which is what these are, is we would apply one of these two formulas. Depending on the information you are given determines if you are using law of sines and cosines. There are two situations in which you use law of sines, and then there's two situations in which you use law of cosines. So it all depends on the information given. And you can't use the other one. It's not like you can mess it up. You literally do not have enough information to use the other one. So the good part of law of sines is its formula, okay? It's the easier of the two. The ratio of the side length over the sine of an angle is equal to the ratio of the other side over the sine of its angle, and then vice versa, and then also for the third side. We will do these in pairs. So if I'm given information about angles A and B or sides A and B, then I will use those two. A over sine of A equals B over sine of B. If you're given the information about B and C, then you would use those two. B over sine of B equals C over sine of C. And if you were given information about A and C, then you would use those two. So you would use any two of these. Just set them equal to each other. And then you literally cross multiply and divide. So if we can solve a proportion, that part's the easy part. This also can be switched. So notice on the bottom right, the angle part is in the top. That's fine. It doesn't matter. As long as you put sine with the angle. And as long as you're consistent with the other two. Okay? And these are used for what are called oblique triangles. Oblique means not right. Okay, so if it was a right triangle, we would use SOHCAHTOA. These are not right triangles, so we can use oblique. They could be acute or obtuse. Okay, this is just where the law of sines comes from. I will never test you on this, but if the question is how does it happen, if I took my oblique triangle and I drew the height of it, now I've made it into two right triangles, and I can set up the ratio of the sides based on that. So if I use the height for one side, I could say the sine, let's say B is here. I could say the sine of B is the height over, let's say this side is A. And then if this angle is A, then it would be the height, or the sine of A would equal the height over B, which would be this side. And then I would solve them both for H. I would substitute them in for each other, and then I could set them into a proportion. So again, you'll never be tested on this, but this is where it comes from. If I had added a height into a triangle, then I can set up a systems of equation and use substitution to solve for it. We're just going to trust the equation because it's way easier. And again, they're oblique triangles. So they're triangles that do not contain a right angle. We cannot use Pythagorean theorem to solve these. All right, so first example, and sometimes they're going to be drawn out for you, and sometimes they're going to be written. Your quiz will be written. There is no picture. So if you need to draw the picture, okay? The quiz would say something like angle A equals 20 degrees, angle C equals 43 degrees, and side C equals 32. That's what it's going to look like. You need to know that the letter goes opposite the letter. So like angle C and side C are opposite each other. That's how you would know where to put the placement of those things. So the first thing you want to identify for law of sines is which of the letters do you have both the side and the angle of? C. So I'm going to use C over sine of C. And again, I could reverse that. It doesn't matter. Equals the other letter I have one of them of is A. So I'll use side A over sine of angle A. So then I would do side C, which is 32, over the sine of angle C, which is 43, equals side A, my unknown, over the sine of angle A, which is 20. Then I'm going to cross multiply. So 32 times the sine of 20 equals A times the sine of 43, and divide. And side A is going to equal, and I'm going to type that all into the calculator. Be careful if you're going to do it step by step, I would do 32 sine 20, hit enter, then divide it by the sine of 43. If you want to put it in fraction form, you totally can. What'd you get? Did anybody get a negative number? If you left your mode in what? It's going to give you a negative number. Radians. We have to now be in degrees. So 32 sine of 20 divided by the sine of 43 gives you 16.0479. And we're going to round these to 2 decimal places for now. It will tell you either hundredth or thousandth. Just pay attention to directions. Again, make sure you're in the right mode. If you're in the wrong mode, it's going to mess it up. All right, so now when it says solve the triangle, it means find all the missing parts. I had angle A, I had angle C, I had side C. That means I need to find angle B, I need to find side B, and I need to find side A, which is what we just found, 16.05. How can I find angle B? So how do I find the angle? Good. It's a third angle in a triangle, right? All 3 angles add up to 180. So I'm going to do 180 minus 43 and 20. And I get angle B is 117. Now I have all this information. I have 16.05. I have 117 degrees, okay? I need to find side B, which means I'm obviously using B. But then I could use the A values or I could use the C values. What would be the benefit of one over the other? Good. I found A, which means 1, there could have been an error in me finding it. 2, I rounded it, which means it is not as accurate as the original one. So you always want to go back to the original information that they gave you, which was the A stuff, or no, the C stuff, sorry. So I'm going to use C over sine of C equals B over sine of B. C was 32 over the sine of angle C, which is 43, equals B is my unknown over the sine of angle B, which I just found to be 117. And then I cross multiply 32 times the sine of 117 equals B times the sine of 43. And I divide both sides by the sine of 43. So 32 sine 117 divided by sine of 43. And I get 41.806. So B equals 41.81. Questions? Now, when you look at these like measurements, they should make sense logically. The smallest side should be opposite the smallest angle. The middle length side should be opposite the middle length angle. And the largest side should be opposite the largest angle. If there's a huge jump in size, then there should be a jump in the size of the sides as well. So like keep that stuff in mind. Questions? And we're going to jump into the ambiguous case. So here's the catch of law of sines. The easy part is the angles. The hard part is the ambiguous case. An ambiguous case occurs depending on the information you are given. It can only occur if the information you are given is 2 sides and the non-included angle. So if you look back onto what we just had, this is what we just worked through. The information we were given was 2 angles and the non-included side. So this would have been angle, angle, side. The ambiguous case cannot happen with that, okay? The ambiguous case can only happen if it's 2 sides and the non-included angle. So if your acronym smells of bad words, forward or backwards, that's when your ambiguous case can happen. And an ambiguous case means that those measurements can actually make up 3 different scenarios. 1, there is only one triangle. 2, there is no triangle. 3, there are 2 triangles. So the one triangle could be something like this. It could be either one regular oblique triangle or one right triangle. The no triangle would be a situation like this, in which no matter where I put this side, using the given angle, that side would never touch the other side. It just couldn't reach it, so it wouldn't make one, okay? That would be a no solution or no triangle scenario. And the third is 2 triangles. The reason this happens is because if I use the measurements that they give you, you might draw the angle that way, and it makes one triangle. Or you might swing this leg out using the same length of B, the same angle for A, but swing outside A, and it makes a completely second triangle. In those cases, you will have 2 sets of answers. You will have an A1, a B1, a C1, whatever it is that you're looking for. We'll literally have 2 sets of answers, okay? So the way we approach this is that we literally go into these ambiguous cases assuming there is a second triangle. And then if you prove yourself wrong, that's how you know there's only one. But we assume there's always a second triangle until you prove yourself wrong. So this is kind of a step-by-step. When you're given 2 sides and the non-included angle, you're going to use the law of sines to find the first missing angle. And we're going to call that whatever variable 1. So if we find A, then it's A1. If we find B, it's B1. If we find C, it's C1. Then to create our second triangle, this is where the second triangle comes from, I take the original angle I just found and I subtract it from 180. I'm finding its supplement. I'm going to continue to solve the first triangle. If I get an error, that's when I would have no triangle, which you'll see an example of each of these. And then I will go back to the second triangle and I will finish out that second triangle. Step 4 says subtract the original angle NB2 from 180. And if it's negative, there's no second triangle. That's how you know there's only one. You can also add original angle and B2 or C2 or A2, whatever you find. And if it's greater than 180, then there's no second triangle. So we're going to walk through like one of each of those scenarios so you can kind of see what they look like. But this is basically, this is the catch to law of sines, is the ambiguous case. All right, so first of all, again, you have a picture this time. Without a picture, you would have been given angle A equals 81 degrees, side A is 20, and side C is 12. So if I have one matching letter and another letter for a side, not an angle, this is when I have angle, side, side, or side, side, angle, and that's when I have to make sure I check for the second triangle. It's not going to tell you. You have to know to check for it. So which completed ratio do you have? A. So I'm going to do A over the sine of A equals, the other letter we have is C. So C over the sine of C. So I get 20 over the sine of 81 equals 12 over the sine of C. Then I cross multiply 20 times the sine of C equals 12 times the sine of 81. And divide. And I get the sine of angle C equals, and I'm going to type that whole thing in, 12 sine of 81, hit enter, divided by 20. And what I get is like 0.592613, so on and so forth. Is that angle C? What's the left side of this equation say? It's the sine of angle C. So if I have the sine and I'm looking for the angle, what do I have to do? Good. I'm going to do sine -1 of that answer. Don't round it. Keep it complete. So second sign, second answer on your calculator gives me angle C, and we're calling it C1, equals 36.34. Now, the moment I get that on a situation in which you have side-side angle, I immediately start a second triangle so I don't forget. Second triangle, and I find angle C2. So whatever I just found, which was C, I'm going to find its supplement. I do 180 minus what I just got, 36.34. And I get angle C2 equals 143.66. Now I still have to go back and finish my first triangle. I'm not done there. But let's check to see if there even is a second triangle if I wanted to move forward. In order for there to be a second triangle, if I add what I just found, whatever that 2 is, so C2, and the original angle that was given, there's only going to be one original angle that was given. If it's bigger than 180, I'm done. There is no second triangle. If it's less than 180, I have to continue and solve the second triangle. So is 143 plus 81 going to be bigger than 180? Yes, which means this case, there's only one triangle. There is not a second triangle. So now I have to finish out my first triangle. My first triangle, I was missing angle B, I was missing angle C, and I was missing side B. I just found angle C, 36.34 degrees. Now I gotta find both B's. How do I find angle B? If angle C is 36.34 and angle A is 81. Good. So angle B is 180 minus angle A, which was 81, minus angle C, which is 36.34. And I get angle B is 62.66. And then the last thing I need to do is find B. So I'm still using A, the original information. A over the sine of A equals B over the sine of B. A was 20 over the sine of 81 equals B over the sine of B, which we just found, 62.66. I cross multiply. And divide. Sine 62.66 divided by sine of 81. And B equals 17.987, so 99. Question on these. Okay, these obviously take a lot of work. You got to be really careful. It's easy to make it one little mistake, and then if you carry through a mistake, it's going to make everything else wrong. So you got to be really careful. Good? All right, let's do another one. So again, look at what you've got. You've got two sides and the non-included angle, okay? What does included angle mean? But where the two sides meet, right? So if I had A, B, and angle C, that's side, angle, side. That actually we use law of cosines for, okay? So it's important you understand that what you use law of sines for and has the ambiguous case is two sides and the non-included angle. So two sides and an angle that is not between them. So again, I make sure I check for a second triangle here. On your quiz, they're going to get mixed in. You got to be careful. You got to make sure you should know what it is you're looking for. All right, so I have the full ratio of A's again. So I'm going to do A, which is 12, over the sine of A, which is 69, equals, the other thing I have is the side of B. So B over the sine of angle B, and we're going to call it B1 because we're going to assume there's a second triangle until we see otherwise. Then we cross multiply. 12, the sine of B1 equals 15 sine of 69, and then divide both sides by 12. And I get sine of B1 equals that whole thing, 15 sine 69 divided by 12. And you can actually sine -1, the fraction containing those whole things, or you can do second sine, second answer. What happens when you, first of all, what's the answer of 15 sine 69 over 12? What do you get? You get 1.1669. And if I second sine or inverse sine that, what do you get? An error. Why do you get an error? Sine is greater than 1. Can sine be bigger than 1? No. Can't be 1, it can't be bigger than 1. Okay, you're basically saying the hypotenuse is smaller than the opposite side, which can't happen. So this is the scenario. This is the one you like because you're done. This is the one in which there is no triangle. So these side lengths, like if I literally gave you a piece of string that was 15 centimeters and a piece of string that was 12 centimeters, and then I said make an angle with a third side that was 69 degrees and connect these, they wouldn't connect. It physically would be impossible for these side lengths to connect. That's when it's a no triangle scenario. Those are the ones we like. Camilla. Yeah. Yeah. And it will give you the error. Yep. All right, we did one triangle. We did no triangle. What do we think is going to happen? 2 triangles, just for fun. All right, again, 2 sides, non-included angle. Again, full ratio is the A's. So 12.3 over the sine of 62 equals B, which is 13, over the sine of B1. Cross multiply, 13 sine of 62 equals 12.3 sine of B1. And divide. And I'm going to sine -1 that whole sucker. And I get angle B1 equals 68.94. And I'm going to check for a second triangle. So we're going to find B2. How do we find B2? Good. 180 minus B1, or the supplement to B1. So 180 minus 68.94. And I get angle B2 is 111.06. How do I check to see if I continue with triangle 2? Add it to the original angle that was given to you. So if 111 plus 62 is 180 or bigger than 180, I'm done. But in this case, 111 plus 62 is 173. That is less than 180. That means there is a second triangle. So to find the last angle there, which would be angle C2, I would do 180 minus A1, which A is the same for both triangles. A carries over because that's what was given. And the 111.06. So 180 minus the 173.06 tells me angle C2 is 6.94. So when I'm writing out these answers, I'm going to have an angle B1. I'm going to have an angle C1. I'm going to have a side C1. Then I'm going to have an angle B2, an angle C2, and a side C2. I just found B2, that's 111.06, and I just found C2, that's 66.94. So then to find the last one, the last side for the second triangle, I have to set up a ratio. I always go back to the original ratio that was given to you, which is the A's. So I keep going back to that. A, which is 12.3, over the sine of angle A, which is 62, equals, I'm missing side C2, over the sine of angle C2, which is 6.94. Cross multiply. And divide. 12.3 times the sine of 6.94 divided by the sine of 62. And I get C2 is 1.68. So I finished the second triangle, but I didn't finish my first triangle. You could have finished the first before you finish the second. It doesn't matter what order you do this. Just don't forget about your second triangle.
Oh, is 13 the B for both triangles?
Yes, the given information, right, that was one that's given to you. Whatever is given to you at the beginning is true for both triangles.
Oh.
Yep. So now I'm going to go back to the first triangle. I found angle B1, that's 68.94 degrees. And now I got to find angle C1 and side C1. So I have two of the three angles. To find angle C1, I'm going to do 180 minus A, which was originally given to you, minus B1, which is 68.94. And I get angle C1 is 49.06. And then the last thing I have to find is side C1. I have the A's. I always go back to the A's. So 12.3 over the sine of 62 equals side C1, which is what I don't know, over the sine of angle 49.06. This is where you have to be so careful, especially with C's, because your lowercase c's look like just like your uppercase c's. Like, just make sure you're really careful you know what you solved for. 12.3 times the sine of 49.06 equals C1 times the sine of 62. And then divide both sides by the sine of 62. And I get 12.3 sine of 49.06 divided by the sine of 62. 10.52. These are the worst ones. They're the worst ones in the whole, like, out of both sections, to be honest. Okay? They're obviously tedious. They're obviously a lot of work, so they can find one little mistake typed wrong, punch it, whatever it is. You have to be really, really careful. These are also like the same thing on repeat. So like if you do it tonight for homework, you do it again on the warm-up tomorrow, you do it on the quiz review. Like by Friday, this process should be second nature to you. Is it annoying? Is it tedious? Yes, but it is a step 1, step 2, step 3, and repeat. Okay, so it shouldn't be awful. Questions? Yeah.
Is there not a B2?
The B is what was in for both. Like you mean side or angle?
The side.
Side, so B was given to us at the beginning. Those three things that are given to you at the beginning are true for both. Yeah.
So that's why I didn't do it.
Only what you find, you have to find two of. Yeah, sure. Other questions? All right, so the good News about this section is the area is so very easy. Okay? There's an area formula in this section. There's an area, so we're going to learn 2 area formulas, law of sines, law of cosines. That's what you'll get quiz on Friday. The area formula, this is what happens if I don't know the height. So like if I have a triangle, obviously if I have a triangle and I know the base and I know the height, I can just use 1/2 base times height. Okay? The thought process here is what happens when you don't know the height. Well, I could derive it. I could do what we just did in the beginning. I'd draw the height, figure out the relationship between the sine and the bottom. But you don't have to do all that. You could use this formula, which is 1/2 2 sides times the sine of its included angle. So each of these can be used, okay? If I have A and C, then I'm going to use angle B. If I have sides B and C, I'm going to use angle A. And if I have side A and B, I'm going to use angle C. So it is 1/2 product of the sides times the sine of the included angle, or the angle where they meet. Typically, that is all you're going to get. You're going to get side A, side B, and angle C. And it's super easy. You just have to remember the formula. So see, example 6 says find the area of the given triangle. What 2 sides are you given? B and C, and then the included angle, which is A. So I do 1/2 B, C, sine of A. 1/2, 5 times 6 times the sine of 71. And literally type it in your calculator. 14, I think these usually say nearest tenth, so we're going to do that. 14.18, which is 14.2. And it's area, so it would be unit squared if it gave you the unit. Yeah. Yeah, no, it's fine. Like, I'm not going to mark it wrong if you don't have the unit. But if it gave you a unit and it said to keep the units, that's what it would be. Okay. All right, we're going to save the word problems for tomorrow. Okay. And we're gonna do the area off of law of cosines tomorrow. So we're going to start law of cosines, but not the law of cosines part, the actual area part. This homework will be due on Wednesday. Okay. So this homework assignment is in 2 parts. Okay. There are questions on WebAssign, and then there is a PDF. WebAssign does not do the ambiguous case, which is why you're getting the PDF, okay? You have to make sure you do both, okay? The PDF obviously includes the practice for that ambiguous case. You need to do both in order to get credit, okay? If you save it all for tomorrow, it's going to feel like a lot. So my recommendation is certainly start it today so that it doesn't feel that way. You have 8 minutes if you'd like to start it now, okay? If not,